Hi guys, I hope you're ready for week 4 of online learning. We are moving through our review of Algebra 2. Remember this poster I had in my class last year? Well, we have already reviewed linear functions and quadratic functions. You guys did that last week. And we're going to continue this week reviewing quadratics as well as polynomials as we move through the list of functions that we mastered last year in review. So today's lesson is going to be called Advanced Factoring, and we're going to factor some quadratics and some polynomials. Factoring is one of those skills that you need in your algebra tool belt. You'll use it all the time, just like you use addition, subtraction, multiplication, division, all that kind of stuff. Okay, so I've got a blank page for us to use for that. Advanced factoring. All right, so advanced factoring is what we'd use when we need to factor something that's a little bit more than just a quadratic equation that has x squared in the front. So I'm talking about something like this. What if you had the quadratic 3x squared minus 15x minus 18? If you had that quadratic, you would want to first factor out a GCF of 3, greatest common factor of 3. That would leave you with x squared minus 5x minus 6. And then it would be much easier to factor it once you pulled that 3 out of all the terms. You guys are good at factoring these kind. Some of you really good. This one's going to be minus 6 and plus 1. And so in solving this, we have two possibilities. X could equal 6 or x could equal negative 1. And we got two solutions, and it's a second degree equation, if that makes sense. All right, let's try a little bit more advanced factoring one. Let's try 6x squared plus 11x minus 10 equals 0. There's no GCF that we can pull out for this one. So we're stuck with trying to figure out two numbers that multiply to give us 6 on the front and two numbers that multiply to give us negative 10 on the back. It's probably better to start with the back numbers. 10 could be 10 times 1 or 2 times 5. One of them is definitely going to be positive and one negative to give us that negative 10. And I always start with the ones that are more in the middle range of numbers instead of the extreme high and low. So I'm going to go with the 2 and the 5. Okay? Now 6 on the front end could be 6 times 1 or 3 times 2. Again, I'm going to go with the middle of the road numbers, and I'm going to try 3x and 2x. Remember, this is my guess and smile check method. So 2x times 2x is 4x. 3x times negative 5x is negative 15x. When I check those middle two terms, they actually add up to negative 11, not positive 11. That means that I've got my signs wrong. I wanted to get positive 11x in the middle, but when I add these two up, it comes out negative 11. So that's easy. I'll just switch this to plus and switch this to minus. So now I have this quadratic equation broken down into smaller parts. I set each part equal to 0, and I can solve these using my algebra skills. They're not going to be nice numbers, are they? The last time we got nice integer values. Now we're going to get 2/3, a fraction, and negative 5/2, another fraction. That's okay. All right, let's try another one. What about 4x squared minus 19x plus 12 equals 0? Whew, again, that one seems challenging. There's no GCF that I can pull out to get that 4 away from the x squared. So I'm going to have to just try breaking it down. 4 could be 4 times 1 or 2 times 2. 12 could be 12 times 1, 2 times 6, 3 times 4. I'm going to start with the 3 and the 4, and notice that we have a negative sign here but a positive here. That's your clue that these are both going to need to be negative. All right, I'm going to try the 2 and the 2. Again, I usually start with the lower numbers or the ones that are in the middle range instead of the extreme 12 times 1 or 4 times 1. If I do my smile check on this, I'm going to get negative 6x and negative 8x. That does not add up to negative 19. Let me try switching the 3 and the 4. Let's see if that works. If I switch the 3 and the 4 to make it 4 and 3, I get negative 8x. Oh, maybe that's the one that I had before. If I switch it, if I put the 4 here, no, it doesn't work. Oh, because it's 2 and 2. Duh. All right, that doesn't work. All right, so I'm wondering about the 4 and the 1. I just have a hunch. Let's try the 4 and the 1. What if I did the 4 and the 1? Aha, that's what I was thinking. And we're going to do the 3 and the 4. I see it. Sometimes it just comes to me. I get a little hunch that this is going to work. The reason I thought it was going to work is because I saw that 16. 4 times 4 would give me 16, and 3 times 1 would give me 3, both of them negative, adding up to 19. So here's the correct factorization. Again, I broke that complicated quadratic equation into 2 smaller parts. I set each part equal to 0 and solved them separately. So I get 3/4 and I get positive 4. So, works out well. A little bit more advanced factoring. Okay, let's see. What if they give you a quadratic and they don't set it equal to 0? It's not a big deal. For example, this one, negative 16x squared plus 6 equals negative 4x. It's a quadratic. To solve it, we set it equal to 0, and we either factor it or use the quadratic formula. I would rather have this 16 be positive, so I'm going to move the 16x squared over here. Then the negative 4x was already over there, and then the 6, when I move it over, will become minus 6. Ooh, now this one does have a GCF of what, 2? 2 goes into 16, it goes into 4, and it goes into 6. So that at least breaks it down a little bit. I need negative 2 in the middle. I'm going to go for 4 times 2. And, oh, there's only one option for 3 and 1. 3 and 1. One's going to be positive and one's going to be negative. 2x and negative 12x. That didn't do it for me, did it? Let's try switching the 3 and the 1. If I put the 3 here and the 1 here, let's try that. I get 6x and I get negative 4x. I'm so close. I got positive 2x. So let me switch the signs. That's going to make that negative 6x and positive 4x. There we go. Okay, now we have 3 things equal to 0, but 2 does not equal 0. So it's not the 2 that's causing this product to equal 0. It's got to be one of these 2 that has the x. Either 4x minus 3 equals 0 or 2x plus 1 equals 0. That gives me x equals 3/4 or x equals negative 1/2. All right, advanced factoring. All right, now those were all quadratics that I gave you, but we're ready to move on to polynomials, and polynomials need to be solved as well, which means they need to be factored. So for example, here's a cubed polynomial. 3rd degree polynomial. So if you were trying to solve this, it's set equal to 0. You want to break it down into smaller parts, which is called factoring. The nice thing about this one, look at all the coefficients. They're all divisible by 4. That's nice. Let's pull that out. And they actually all have an x. All the terms have an x. So let's pull out that common x. That leaves me with x squared minus 5x plus 4. So now I can factor the quadratic that remains. Ooh, that's a nice easy one. Minus 4 minus 1. And now I have 3 solutions. I have x equals 0, x equals 4, or x equals 1. 3 solutions because it factored into 3 separate factors that have a variable in them. Okay, the next one. Let's try this one. 20x to the 4th plus 7x cubed minus 3x squared equals 0. Right away, lots of x's, right? Let's factor out the GCF. All of them have at least x squared in them, so that's a common thing that they all have. We'll pull it out. That leaves me with this. 20 in the front. That's a big number. I don't know if I want to do 20 times 1. I'm going to go with 4 times 5. And then, 3, there's only one way to get that. Let's see, 3 and 1. Is that going to be 7 in the middle? One of them is going to be positive and one of them is going to be negative. Let's go with positive here, negative here. Do my smile check. Negative 5x, positive 12x. It does give me the 7x in the middle that I need. Got lucky on that one, but I had a hunch that it was going to work out. All right, now that it's factored, we get something from each of these. We get x squared. Whoops, I think my pen just turned off. We get x squared equals 0. So x equals 0 is one of our solutions. It's actually a double solution. You guys might remember that double solutions are graphically significant. This one gives me x equals 1/4, a fraction. And then this one gives me x equals negative 3/5. Okay? So we got 4 solutions to a 4th degree polynomial. And I say 4 because x equals 0 was actually a double solution because it was x and x from the x squared. Okay, now, sometimes we have to factor and there's no GCF. So there's a couple of patterns that you may come across that you should have somewhat memorized. These are hard ones to remember. The sum and the difference of two cubes. I know we put these on the sideboard last year because they are hard to memorize. There's the sum of two cubes, and here's the difference of two cubes. If you see a polynomial like that, a 3rd degree polynomial, you can factor it. This one factors into a plus b times a squared minus ab plus b squared. And this one is a minus b. It looks exactly the same except the signs are the opposite. They're both plus b squared on the end. So an example of something like that would be, let's try this one. 2x cubed plus 128. Okay? If you had to factor that, well, you first see that there's a 2 and 128. Those both have a factor of 2, so you can at least pull that out. That's going to be 64. And then 64 is 4 cubed. So it is a sum of two cubes. It is this right here, a cubed plus b cubed. We have x cubed plus 4 cubed. So this is going to factor into, the 2 stays out in front. This is going to be x plus 4, following the pattern up here, parentheses x squared instead of a, minus a times b, which would be 4 times x, or x times 4, plus b squared, which would be 4 squared, so 16. Now, you might think that this should factor more. It looks like it would, but it doesn't. If it did, the formula would tell you to do that. But this is as far as it goes as far as factoring goes. So if you had to solve this, you've got x plus 4 giving you x equals negative 4. But this one, since it doesn't factor, you must use the quadratic formula. And I'm not going to do that today. You did that and practiced that last week. But if it won't factor, that's when you have to use the quadratic formula. And I'm guessing what you're going to get is 2 imaginary solutions, most likely. You're going to get 2 imaginary or irrational solutions from this one. Okay, now, there is one other possibility for types of factoring that you may not have seen for a while. Besides sum and difference of two cubes, you might see something like this. How about this one? 5x to the 4th. Oops, lost my pen again. Okay, 5x to the 4th plus 5x squared minus 10 equals 0. Okay, 4th degree polynomial, but it only has 3 terms, and I notice right away all of them have a common factor of 5. At least we can pull that out. We can't pull out any x's because the last term doesn't have an x in it. So we're going to have to leave the x's in there. Now, this is a 4th degree polynomial in the parentheses here, but the way it's set up with 3 terms like that, it almost looks like a quadratic. So think about how you break x squared down into x times x. Let's try breaking x to the 4th down into x squared times x squared. Same idea. They call this the quadratic form, even though it's not quadratic. And then the 2 and that could factor into plus 2 minus 1. I love it. And then this is my favorite. That's a difference of 2 squares. That factors to me in a really cool way. X plus 1, x minus 1. X squared plus 2 does not factor any further. So as far as solutions go to this polynomial equation, we're going to get x equals negative 1 and x equals positive 1. You knew that. And then watch what happens here. We set x squared plus 2 equal to 0. We move the 2 over. We take the square root of both sides. And there's our imaginary friend, I. The square root of the negative gives me I. The 2 is not a perfect square, so it stays inside. And whenever you take the square root of both sides, you get 2 solutions. So there you go. 4 solutions for a fourth degree polynomial. 2 of them were real, 2 of them were imaginary. And we know that there's graphical implications to that. These 2 would be visible as zeros. These 2 would not be visible as zeros because they're imaginary. Okay, I hope that'll be enough to get you started on factoring. You can do this quadratic form factoring if it's x to the 6th or even higher. Just think of it as being like a 3-termed quadratic, but break it down into, instead of x times x squared times x squared, or x to the 3rd times x to the 3rd. All right, thanks for watching. Bye.